Okay, this is a more difficult solution. We have root x plus 1 inside of a set of parentheses, and that is squared in the denominator there. Next to that is a root x. All these things are in the denominator, and there's just a 1 in the numerator. And the goal is to figure out what to let u equal. And sometimes this is the hardest thing. If we can identify something that is definitely can be represented as being inside, then that's the first hint that maybe that should be u. So this root x plus 1 is inside of the set of parentheses, and it's then squared. So we're going to try that out. Let u be the root of x plus 1. The plus 1 is not underneath the root. Only the x is under the root. So you're going to take its derivative. The derivative of root x is 1 over 2 root x. If you need to, just use the half exponent. Bring the half down, take x to the negative half of the power rule, and this is what you get. So then that's encouraging because the rest of the integrand has the 1 over root x dx. We have this integrand here, which is 1 over root x dx for the rest of it. And so that's looking good because that's what we have here. Except for we have this extra factor of 2 in the denominator, which came from the power rule. You know, x to the half is what u is, and so its derivative is half x to the negative half. And so that's how that 2 got down there, and that's how we got the 1 over 2 root x. And so there's this 2 down here, and so there's no 2 over here, so we just multiply both sides by 2. And so now we know exactly how to replace 1 over x dx. 1 over x dx gets replaced by 2 du. So this root x plus 1 gets replaced by u. This is going to be replaced by u, and that's u squared in the denominator. And then the rest of this 1 over root x dx, or dx over root x, we found out that that gets replaced by twice du. Okay, and what's the goal? The goal is to get to a simpler integral, and we definitely have it. We're going to pull out the constant 2 and look at 1 over u squared. It's tempting to think of, oh, 1 over something, I should do a natural log, but no, that's not the case. That's only when it's to the first power in the denominator. And so we have this is to the second power here, and so we just once again appeal to the power rule and rewrite it as u to the negative 2. And we use the power rule where we bring it down. Actually, now it's the power rule in reverse. We have to add 1 to the exponent and divide by exactly the same thing. So u to the negative 1 divided by negative 1. And notice there's this plus c involved now, because when you don't have limits of integration, then it's called an indefinite integral. And so it's just a fancy way of asking you to find the antiderivative of the integrand. This question is saying, in essence, find the antiderivative of that function there, which is 1 over root x plus 1 quantity squared. That's what they're asking. And so, anyway, we're on our way to getting that. We had to do the substitution to help us out, and now we can go back in and replace, you know, the negative exponent was great to be able to find the antiderivative, but now we need to go back and back to the positive version of the exponent. Negative can just be part of this, so it ends up as negative 2 all over u. Okay, so negative 2, u to the negative 1, or negative 2 over u. And then we're going to change back into x. And what was u? U was the root of x plus 1. And so that's in the denominator as the root of x plus 1. The negative is there from here. The 2 is there from here. And so this is our answer to the question. The question was for us to find the antiderivative of that function, and we can double check that we've done the right thing by taking the derivative here, and it should end up as exactly what the integrand is.